So, good morning, everyone. Can't believe we have reached the end of another semester. And as we say back in our country, in Brazil, to close it with a golden key, we're going to have an awesome talk, which I've been very much looking forward to hear to. I am Paula Furlaneto, and I am the president of the UMass student chapter of Informs. And along with our advisor, Dr. Naguni, we are so happy to be receiving Mr. Jack Levis here today. So Mr. Levis is retired UPS Senior Director of Industrial Engineering. He was responsible for development of operational technology solutions, so very dear to all of our hearts. These solutions required advanced analytics and re-engineering processes to streamline the business and maximize productivity. He has been the business owner and process designer for UPS package flow technology suite, a suite of systems which includes its award-winning delivery optimization, Orion. So these tools have been breakthrough change for UPS, resulting in a reduction of 185 million miles driven each year, reducing costs by 150 million to 400 million per year. And as somebody who works with environmental, I would say probably reducing a lot of local air pollution. Mr. Levis is a fellow of the Institute of Operations Research and Management Science, our dear Informs. He has received the Presidential Kimball Medal and the President's Award. His education background includes a Bachelor of Arts in Psychology from California State University of Northridge, and a Master's Certificate in Project Management from George Washington University. So please welcome to this most renowned speaker, and we are so looking forward to hear from you. I will pass to Professor Naguni if she wants to say some remarks.
Thank you everyone for coming, and many thanks to Mr. Jack Levis. It's such an honor to be hosting him in our speaker series. He's amazing, so we're absolutely thrilled and looking forward to this talk so much.
Okay, well, thank you. My pleasure to be here. I love Informs and I love Anna, and so it's my pleasure. I worked at UPS for 43 years. And I'm going to go through about what I worked on about the last 20 years. We're going to go over a lot of information in a relatively short amount of time. I'm positive there'll be time for questions, and if there's something really you have a question on during a slide, it's okay to ask, and I will decide whether to do it there or wait till the end. Hopefully this goes well. And the title here is talking about impact and how that takes math and psychology, and you saw that my educational background was psychology, so that's why I think that's important. I think often we think about the hard things, what I call the math, but you need to think about the psychology or the people side as well, and hopefully that'll come through. Maybe a little bit of my grumpiness is going to come through on this slide, but let's talk about innovation for a moment. Often when we think about innovation, people think about getting in a room and brainstorming and ideating and all those nice words. But I always have a question. Is innovation the idea itself, or is it the execution of the idea? Let's listen to a couple of founders. The man on the left founded UPS in 1907. He had $100, a bicycle, and a telephone. And Jim Casey said that inspiration and enthusiasm are of little value unless they bring us to action and accomplishment. So he understood the need for getting things done. Ben Franklin on the right said it much more succinctly. He said, well done is better than well said. So while we need the great ideas, honestly, I'd rather surround myself with people that know how to execute those ideas. And we'll talk a little bit more about that. What I think is the future, and from my biased experience of supply chain or business in general, is you start with data. You need frontline technology on top of that as the second pillar, because you need to visualize the data, interact with it, plan from it, etc. You put on top of that foundation advanced analytics, and that's the math side. Those three things will give a nice system that helps improve supply chain or business. But the psychology side of it is you need leadership and change management. And this is where math and psychology come together. You can't forget the leadership and change management. And I'm hoping that will come through. Let me start with a little bit of background in my belief that you have to pay attention to details and that little things matter. So let me show you some of my little things. When I retired at UPS, 1 mile reduction was worth about $50 million at the end of the year. I didn't have to look at giant things, just 1 mile could help the bottom line by $50 million. Within that is time. So 1 minute of driver's time per day is worth about $14.5 million at the end of the year. And even shutting off vehicles, idle time. A minute of idle time can reduce fuel by $500,000 a year, not to mention the wear and tear on vehicles and the environment, etc. So don't look for giant things. If you watch the pennies, the dollars will take care of themselves. So find a little thing that can be improved over and over again, and you will make a large impact. Second bias is this word. And it's not OR and it's not operating ratio, it's OR. I really didn't like it when somebody came to me and said, do you want better service or reduced cost? That answer is yes. Do you want higher profits or sustainability? That answer is yes. I believe that advanced analytics, frontline technology, and data can help turn OR into and that needs to be our mindset. We're not going to give up one for the other. We will use these tools to be more productive. So let's talk about analytics for a moment. I know you all know this, but let me backtrack, and I don't mean to speak down to you. You know, analytics is about impact, as I mentioned earlier. You know, the focus is impact. It's much different to deploy a tool than deploy impact. And often when people think about analytics, and I've seen this with the supply chain in the United States, the first step is, well, I just want to know what's already happened. Well, that's nice to know, but it's not enough. Describing what's happening or what's already happened isn't enough, because unless tomorrow is like yesterday, it's hard to make a huge impact just from describing. So the key is, do we want to fix a symptom, which is what's already happened, or do we want to fix the problem? And that gets me to this slide, which is my favorite slide to describe analytics. And it talks about analytics in a continuum, starting with the lower left, descriptive analytics, which says what's happened or what's happening right now. Above that is diagnostic analytics that says, why did something happen? And then we move to predictive on the right, what's going to happen next if we continue down a path. And then finally, prescriptive analytics above, which says, what should we do? So analytics goes from where am I, to why am I here, to where am I headed, to where should I be headed? And when you think about it, it's obvious. As soon as you see what's happening now, your next step is, well, is this going to happen in the future, and what do I do about it? This slide points out that as you move through this continuum, you start moving from looking at the past and present to looking at the future. And obviously, when you start looking at the future, things happen. Your business impact grows, and that's the most important part of this. Now, also, your data needs will grow, your skill set needed by your people will grow, and as I said, your business impact grows, which means that an organization should not have their sights end at describing or even predicting. Your vision needs to end at prescription or optimization. This was my experience exactly. We didn't have these words, but we deployed a suite of tools that included describing and predicting, diagnosing in 2003 that ended up reducing about 85 million miles driven a year. We put on top of that suite of tools some optimizations that when I retired reduced an additional 150 million. Or actually when I retired it was 100 million miles a year. But since then it's gotten better and it's an additional 150. So Overall, UPS has reduced its miles driven by about 235 million miles driven annually by doing exactly what I mentioned. Now, looking at this another way, you go from data to information to knowledge and then wisdom. And I say wisdom because when you start optimizing and put that true advanced analytics on top of this set, on top of this foundation, a new employee, a new planner, UPS's case, a new driver, performs as well as someone who's very seasoned and has done the job a long time. The suite of tools provides that type of wisdom. So let's talk about data for a moment. I mentioned on the previous slide that your data needs change as you move from describing to predicting to optimizing, and they get more pristine. Initially, we had to focus on this person. This person loads the vehicle for the driver. You can see the shelves in the vehicles. The packages are loaded in a general order that a driver is going to deliver. And we knew the value of a minute, so we wanted to make drivers efficient by having every package in the right vehicle and in the right location so that they don't spend time looking for packages. What we did initially was spend about 9 months doing nothing but analyzing data. What information does this person use to make decisions? Make sure the data model can answer any question that comes out of operations and tell us what to do with a delivery. Think of it as the UPS data model, UPS digital twin. Sometimes we call it a virtual network, but regardless, it's data that describes UPS. It describes the business. And my point is these models need to be forward-looking, not backward-looking. Then we built frontline technology to cover all the portions of the operation, planning deliveries, while the operation's running, the ability to adjust the operation, to monitor it, communicate what needs to happen, and then have some other ways to analyze and make sure the operation's running all the time. When you think about it, it follows the Shukert cycle of plan, do, check, act. So in essence, you build a suite of tools that support the job. The tools and the job and the data just become one. Let me show you an example of what the tools would have been and how the forward-looking models would look. You can see textually on the left and geographically on the right all the deliveries that UPS would plan to make for a day. Now, today is Friday, so UPS is now planning Saturday, Monday, and some of Tuesday. And think about it, those packages aren't even in the system yet. So we built some forecasting models that can look ahead, take historical data as well as data we have, and decide where we believe deliveries will occur in the future. And you could see that geographically on the right. Every square is where we think a delivery will occur for future operating days. Now, the system now has fun because it can analyze those deliveries and come up with information for the planner on routes that the system thinks have too much work, too little work, or inefficient work. And you can see this route here is highlighted in red. The planner now needs to decide what to do. So the planner will grab some territory, again, geographically on the right or textually on the left. And in this case, if you see it, the planner grabbed 9 packages and 9 stops and 12 packages to move from one route to another. You see the little circles? Those are places where deliveries might occur. So we're going to move all of that from one driver to another, just in case a package shows up in a place that we didn't forecast. Now, we do need to make sure we communicate to the people doing the job. Communication of analytics is as important as anything. And in this case, a little label will print out just before that loader grabs the package. This package goes into route 120, position 1118. And if you ever get a delivery from UPS, look for that label. That's what was used to decide your delivery for that specific day. We talked about communication. We also need to communicate to the drivers, to tell the drivers what they need to do for their day. In the old days, they knew what they had to do just by touching cardboard in the back of the vehicle. Now it's all in their handheld. They could see what they need to do from starting in the morning. In this case, fill out your driver vehicle inspection report. Throughout the day, they can see all the deliveries they need to make. And if there's any special handling needed, how many packages there are, what time they need to be there. And in addition, where in the vehicle the package is. We made the handheld smarter as well. If a customer requests a signature in this case, the handheld's not going to let the driver leave without getting the signature that we promised the customer. So we tell the driver they need to get a signature, and it's enforced in the handheld. We also then added more data to our data model in the form of notes, things that were in drivers' heads or on their little notepads in their vehicles. In this case, for this customer, it says park at the dock, deliver to the mailroom. But if you look at the last one, that's interesting. That says no indirect, no reroute, no left at. This customer says if I'm not home, don't put the package on my back porch or take it to a neighbor. Come back tomorrow. And this handheld will not allow the driver to leave without following those instructions. The driver is not allowed to make that delivery. They will have to come back tomorrow. Now, another customer may say, if I'm not home, put it to a neighbor on a back porch, on the side of the house or the garage even. And the handheld's smart enough to know through the data the difference between those to make sure that we're serving every customer efficiently. Now, your driver already knows this. Your driver's a professional, they know their area, they're very caring. But what about when that driver's on vacation or at Christmas time when our volume doubles and work is moved from one to another? We are now efficient and provide great customer service any time of the year, regardless of who is running that route. Every time we touch a package with a device, those devices are connected to a cloud. Well, you know what? Our customers are also now connected to the cloud. So rather than scanning a package for tracking, which is 1990s technology, that scan allows us to be connected to a customer. So a customer can play with the exact same bits that the planner plays with. So this is a functionality, a little old now, but on a suite of tools that UPS has for customers. And take a look at some of the things a customer can do. You get a delivery alert of a forecast that a package is going to arrive. It's the exact same forecast the planner gets. You get a delivery planner, it's the exact same one that the planner would have gotten. We're working on the exact same database. If you want to hold a package for a will call, it'll flip the same bit we would have flipped. You can authorize shipment release. You can tell a driver where you want the package to be dropped off at or with a neighbor. It's the exact same things the planner would have done, but we open that up to our customers, all looking at that exact same data model. So let's talk about the impact that UPS received from this suite of tools called Package Flow Technologies. It reduced about 85 million miles driven a year. It reduced about 85 million miles driven a year. Somebody mentioned the environment. That reduced to 8 million gallons of fuel purchased, 85,000 metric tons of CO2 going to the atmosphere. Service levels are at the highest they've ever been. And we offered new products for customers. So we met all the goals that we had for this system by using data, operations technology, advanced analytics. And everything I just told you was a fairy tale. I'm not saying the benefits weren't there. Those benefits I just showed you were understated. But it didn't work like you saw in the headlines. It didn't work like the press releases. It was not as simple as I just made it sound. You don't find a glass slipper and put it on the princess's foot and live happily ever after. It takes a lot more work than that. So I want to show you the psychology side of the job and what really happened as this went into deployment. So when that suite of tools deployed, and put your head on for what 2003 looked like. You know, in 2003, you might have had a flip phone. Only about 10% of us were on the internet. It was hard back then, but we were putting out this digitization platform that had a lot of fanfare, satellite interviews, TV shows. It was groundbreaking. And our CEO went on and told the investors that we'd save about 100 million miles driven a year. Well, what I learned is Field of Dreams is a movie. If you build it, don't assume they're going to come. It's a lot harder than just putting out software. Remember, there's a difference between deploying software and deploying impact. Let me show you the headlines a year and a half later. Package flow technologies is not delivering for UPS. Those were ugly days. A third of our sites got better, a third stayed the same, and a third actually got worse. Our investors were really upset because we told them about all the money we're going to save, and we received nothing a year and a half later. And honestly, I felt like I was on the witness protection program for package flow technologies. Until about 6 years ago, I was not allowed to use that name in public. I couldn't call it package flow technologies. I could call it a data infrastructure. But the investors were so upset that the promise wasn't made that you know, we didn't talk about it. And it was hard to get things done because we were so focused on what went wrong. So what I learned is we built this race car, but we didn't have the infrastructure nor the people trained on how to drive this race car. We had to figure that out. You know, being a data-driven enterprise takes a lot more than just saying data is important. It takes a mindset. It's a cultural change. You know, in essence, the concept needs to be the data is as important as the product. And back in 2003, we didn't really believe that, but we went through those growing pains. And from 2003, for about 3 or 4 years, this was the mantra. The data is as important as the product. We have to get the data right if the tools are going to work. So this is interesting. Remember, we deployed the suite of tools in 2003. In 2013, Information Week named package flow technologies the greatest idea to steal that year. Now, it was 10 years since we deployed. The tool was essentially identical to the same one we deployed, but now it's an innovation. So back to my original question, is innovation the idea or is it the execution of the idea? You need both, but something that was a failure turned into the greatest innovation of the year because we learned how to use it and we deployed it right. This stuck in my mind all the time because thank goodness I worked for a company that was always forward looking. And while we were deploying package flow and fixing it, we were working on the next step. We were working on optimization and prescriptive analytics. Because should that data foundation get right, should we become truly a data-driven organization, the obvious next step was prescribing. It was optimization, and that's what we worked on. So I want to talk about that a little bit and the impact and the counterintuitive nature of optimizations. You know, the concept for optimizing came from this concept of complexity. The concept that the world around us is much more complex than any of us realize. And can we really think on our own through the best way to do things? And that's where prescription comes in. So let's put this into perspective. And I don't mean to talk down to the mathematicians. I know you all understand the concept of permutations, but let's take a look at this and put it into perspective. So the number you see here is the approximate age of the Earth in seconds. So that number is about 4.5 billion years worth of seconds. When I retired, the average UPS driver had about 120 stops. There's more than that now. Let's look at the number of permutations there are to deliver 120 stops. Again, I don't mean to talk down to you, but sometimes you need to put it into perspective and see how complex our world is. It'll eventually stop, but this number might as well be infinite. It's a 199-digit number. And this is where the concept for Orion stemmed. I was sitting with my chief scientist and saying, you know, what can we do beyond package flow technologies? And we came to the conclusion, with all of these options, could a driver on their own really come up with the best choice, as good as we thought we are? Is there not some answer out there that's better than what we're already doing? And the only way to know was to build the optimization. So I'm going to give a little test here and a little description of what I'm talking about. This is a real driver's route in Gettysburg, Pennsylvania. The driver's name is Tim On. Tim, in this example, has about 143 stops, somewhere like that. That green area that you see there is the Gettysburg battlefield. It's a beautiful area. Tim's been driving this route for over 20 years. But look at all those stops he's got to deliver. He starts his day up at the top where that UPS shield is. And how would you deliver that? Think about it. How would you go through those stops? And pretty soon your mind comes to the conclusion that, you know, it's complex. One decision impacts the next and impacts the next. So the best way to do this is more complicated than it seems, even though Tim is not aware of those complications. All right, here's where the test comes in. I'm going to show you two routes. Of all the possible ways Tim could deliver his route, I'll show you two. And the Jeopardy answer is, it's the route with the fewest miles. So don't overthink it. Which of these two routes has the fewest number of miles? Right, I wish we would have set up a voting machine, but I can tell you I've done this countless times. I mean, you know, easily 100,000 people I've shown this to, and it's always 50-50. About half think the one on the left, about half think the one on the right, except once. One time I did this with a class of high school students, and every one of them picked the same route, and it was the one with the fewest miles. And I have no idea how they did it, but that was the only time that we didn't end up at about 50-50. And I've done this with voting machines. I've done it with the US Chamber of Commerce. It's always about 50-50. So let me show you where that comes from and see if this is a little bit of fun for you. That man on the left, his name is David Pogue. He's got a Sunday morning tech show now. At the time, he was the tech writer for the New York Times. And he had a show on Nova. And Nova came out and they wanted to know about optimization and what routes optimization would look like, how a traveling salesman problem worked. So take a look at this and have a little fun.
A new era is upon us. We are living in the age of fast. I'm David Pogue. Join me on a quest to make stuff faster. I'm a rocket man! Sucking ass, man! Sucking ass! So far, the breakthroughs I've discovered in making stuff faster have been tied to the speedometer. Finding ways to cover more distance in less time. But there's a whole other breed of speed. It gets you there faster not because you're breaking a speed limit, but because you're breaking a time limit. It's called operations research or optimization, figuring out the fastest way to complete a task. For example, what is the most efficient way to deliver 16 million packages a day? That's the problem that Jack Levis and his team at UPS are trying to solve. To understand what they're up against, let's pretend I have an Aunt Gertie and I want to send a package to her. So if a 25-stop route has trillions and trillions of possible combinations, imagine how many possibilities there are in the 140-stop route that will take my package to Aunt Gertie. So if the traveling salesman problem is too tough for the world's largest computer, how do you solve it? By building a smarter program. It's called Orion. Now here's the thing. Orion is not looking for the perfect solution. The question, is this better than what a human without a time limit could come up with? With human pride on the line, I decided to pit man versus machine and see if I could come up with a quicker way to get to Aunt Gertie's house and home. All right, so how do I compare with Orion?
The only way to know is to give it a try. You ready to brown up?
Excuse me? I'm ready to put my traveling salesman solution to the test.
You got 4 next day air packages that got to be done by 10:30. This one by 3 p.m. You got business customers that need to be delivered earlier part of the day.
Okay.
Pickups. They can set their watch by the time we get there. Good luck. That's logistics, buddy.
The challenge here, me driving my route and Tim driving Orion's. UPS!
Okay, so what I tried to get across to the producers is life is not a traveling salesman problem. There's constraints that are important that need to be taken into account. We can't do things on what's best for us. We have to do it in meeting all of the constraints. So what I explained to David as he was leaving, those yellow stars need to be delivered by 10:30. Blue ones need to be delivered by noon. Triangles are pickups, and each one has a specific time within a window that they need to be served. And that shaded area in the middle is a business area. And you can't deliver businesses at the tail end of the day. You need to deliver them earlier, give them a chance to get the product, turn it around, and maybe give it back to you for pickups in the future. So there's many more constraints. It's much more complex than a simple traveling salesman problem. And that's what we were trying to show them, and that's the real world. So same 2 routes. I'm sure half of you thought the one on the left had the fewest miles. That was David Pogue's route. If David had beaten Orion, I wouldn't be here. So half of you know that you didn't get the answer right. But let's go ahead and look at how the day ended for David and how he went ahead and drove that route.
UPS! Surprise!
Oh my gosh, what have you been up to?
It's 7:04. David's just now coming in 25 or 30 minutes later than Tim. We got to talk.
My route took 39 minutes longer than Orion's to complete. Company-wide, that would be a loss of millions of hours a year.
I'm sorry, Dave, but I need the Browns back.
You're firing me? Well, I had a good run, but I was no match for Orion. With a plan that would, at best, bankrupt one of the largest shipping companies in the world, it was time for me to move on.
All right, so let's put this together. David's route's on the left. We know that Orion had beaten David, but let's look at the difference. There's a 10-mile difference between what David did and what Orion did. And as I said, I've done this with thousands upon thousands of people, and we can't see as humans the difference between those. How much is 1 mile at UPS worth a day? $50 million if it happened across the fleet. So that means that if every single driver at UPS ran the route on the left versus the route on the right, there'd be $500 million of savings annually, and we can't even see it. I can describe yesterday, but you don't know that there's $500 million to achieve. I could predict tomorrow, but nothing pointed out that there's a $500 million of opportunity sitting there. It wasn't until we built an optimization, made sure it met all the constraints, made sure that it was proper, that we could see a $500 million. It was hidden. One other thing I want to point out, I don't think I have a slide for it. The reason for the firing at the end, and I was not happy with the producers, it had nothing to do with running 10 more miles. That's just dollars. The route on the left that he ran missed service on almost every single package we gave him. He got to businesses and they were already closed. He didn't get to the pickups on time. Almost every delivery was late. So the or versus and, Orion reduced cost and met every single constraint. From my experience, data is always a bottleneck. I've never had an analytics project that data was bountiful. And I thought data was going to be just fine. And I was wrong. My folks pointed out to me, and so now I approach every project saying data is going to be a bottleneck and spend time to make sure that you work through that bottleneck. So let me give you an example of one of the bottlenecks that we had to overcome on Orion, hopefully something that you can resonate with. So if you ever used a navigation system that doesn't get you effectively from one point to another, or in this case, it says you've arrived, but the actual delivery isn't where it says. In this example, that delivery is about 1.2 miles round trip away from where the map said it should have been. That time and distance needs to be accounted for, and we had to figure out how to handle that. Our driver's handheld, of course, has GPS inside of it, and we started gathering data. Where are we when we scan a package? Where are we when we meet a customer? Where are we when we leave? You know, where are we when we get a signature? And we started gathering that data, and it wasn't pretty. You could see that for this one single address, we are gathering the data in different places. Sometimes it's because that's where we met a customer. Sometimes somebody didn't push the button at the right spot. And sometimes it's GPS drift. But through some advanced math, we were able to reconcile that and come up with where we think deliveries in the United States occur. And you could see that here. If you see a green square, that's where the system automatically placed the delivery. So without human intervention, just using math, we came up with these locations for deliveries. I don't see one on this screen, but if the math didn't work out right in one and a user grabbed it and moved it to the right spot, it would turn yellow. But it doesn't look like they had to do any of those in this case. And we end up with a very good picture in the United States of where every delivery is. There's about 250 million data points of locations. But location isn't good enough. It's nice to know where a delivery is. You need to know how to travel there. What's the network to get there? So this took us to the next step of what we needed to do. And I'll show you an example of Walmart and the Hampton Inn. I've stayed at that Hampton Inn many times as we were testing Orion. If you ask your favorite website, how do you go from Walmart to the Hampton Inn? You get an answer something like this, and let me explain it to you. The website knows the geolocation for Walmart. You can see that there, but it draws some dots over to the Lincoln Highway, which is Route 30, because it doesn't know how to get to the Lincoln Highway. It just says you figure it out. It drives you down to the Lincoln Highway until you get in front of the Hampton Inn, but it knows that that's a divided highway and you can't stop there. So it's going to continue down the Lincoln Highway till it finds a place to make a U-turn, tells you to make a U-turn and comes back. And then when you get to the Hampton Inn, it says you have arrived. The problem is where you have arrived, there is no entrance to the Hampton Inn at that location. It happens to be addressed on the Lincoln Highway, but the entrance is on that Sheila Road at the side. For us in our personal vehicles, this is just an annoyance. We see the Hampton Inn, we'll go around the block, we'll figure it out. But imagine giving that bad answer to an algorithm or just as bad a professional UPS driver and saying, here's how you get to a stop. It didn't work. So we had to come up with our own maps. And this, as you see here, is a UPS map. You see the squares as I showed you before. Those are the actual delivery locations. And the lines that we drew in are the travel paths between those locations. If you look at Walmart, by the way, you see that there are 2 squares. That's because if we have a delivery for Walmart, we go to the back dock. And if we have a delivery for the Vision Center, we go in the front door. And if you're ever at Walmart in Gettysburg and want to go from Walmart to the Hampton Inn, this is how UPS says you would go there. Now we had data accurate enough to feed to Orion. But you know, we ran into problems, even though data was great. We ran into problems in getting an algorithm that could think like a driver. And let me show you an example of how there's more constraints than we know. There's more constraints in the world than are obvious or that you might learn in school. And let me show you an example of what we call, are you smarter than a 5th grader? And we call it that because the Orion project manager went to his daughter's 5th grade class for career day. I love this man. He doesn't do anything partway. And he decided he was going to teach his daughter's 5th grade class how to build a traveling salesman problem solution with just math. So he gave them time and distance matrices from each stop. And he said that on a day, you have to go from home, visit these 6 locations, return home. He pointed out to them that there's 720 possible combinations, you know, the concept of permutations. And he asked them just to use math to come up with the best way to route between all these locations that had to be visited on a day. And this is what they came up with, just using a time and distance matrix. And I thought that was pretty incredible that he went ahead and did that with this 5th grade class. But Bob, I told you, never does anything partway. He now decided he was going to teach them what a traveling salesman problem is with time windows. And he gave them those locations and when they're open. And he said, you now have to be there in the shortest time using just the math, but now there's constraints. You have to be in the locations within the window that they're open. And he told them how there's 720 combinations still, but not all of those combinations are feasible. So this is what they came up with. And I would have been pretty proud, as he was, until a little girl in the front row said, Mr. Santilli, this is just stupid. So I don't know if you caught it, the hidden constraint. She said, my mother would never go to the grocery store in the morning and let the ice cream sit in the car melting all day. You know what? We had no constraint for the grocery store. It was implicit. It had to do with things that people know that aren't necessarily showing up in data. And think about that. What are the constraints for the grocery store if you were going to build an optimization around it? I guess you could say the grocery store should always be your last delivery before you go home. But what if there's 2 other deliveries directly on the path home that would just take you 3 extra minutes? Is that now the best choice? We could say you always have to go to the grocery store within 30 minutes of getting home. But what if it's cold? Can the 30 minutes expand? Or if it's hot, does it need to shrink? And what if you have no perishables? Then I can go to the grocery store anytime. And if that's what the rule is, where am I going to get the data to know that there's perishables? And my point is, we spent a number of years with Orion trying to make it think like a human, think like things, and put in parameters that drivers understood. So they didn't think they were interacting with a computer. They thought they were interacting with a suite of tools that thought like them. And it honestly took us about 5 years to figure that out. When we were getting traction with Orion and we realized that it was looking like it was going to work, I did not want to go through package flow again. Did not want to be at the end saying something's not working. We wanted to make sure that we planned that out, that we thought through what problems could happen. So we tested. We lived with drivers. We lived with them every day. We tried to understand how they worked. We would give them an Orion solution, and if they said something wasn't right, we listened, or if they beat Orion, we learned what they did. Something interesting happened in that time frame. Drivers wanted to understand how Orion thought. At some level, they couldn't accept the algorithm answer unless they knew what it was doing and why it made decisions. So we built them a little kiosk that you could see this driver interacting with, and in essence turned Orion from a black box to a glass box. They could interact and say, why did it make these deliveries in the morning? Why didn't it make this delivery at the same time of the other one? And we taught them so that they could go ahead and understand and feel confidence in the solution. A side story, there was an option at the time where we were going to change some of the Orion rules, but it would have broken the logic of what we told the drivers. And so we gave up some of the estimated benefits until we got the acceptance from the drivers. They weren't ready for magic yet. We ran 11 different tests to make sure that we knew that we could deploy this. We wanted to make sure that we could transfer knowledge, that we could train people, that it didn't take an engineer to deploy the system. We want to make sure we had the right metrics and procedures. And we invested 6 days per driver to deploy this system, making sure that the data was right, that everybody was trained. We really knew the impact could be so great. We wanted to make sure we invested up front with everything. We wanted management support, wanted to make sure the C-suite understood. And when we went to the C-suite, we didn't go to them with a promise. We went to them with results of things that we saw during our tests. So let me show you how the tests looked. And this is what we call the Orion Curve. This is what we measured over 4 years, but this happened to be the test results. I think this is probably the actual slide that I took to the C-suite to tell them what we saw during our tests. This line here is a performance metric for UPS, and this is the company as a whole. You can see it's a pretty stable performance metric over time. It goes up and down a few percentage points. That vertical line is when we are going to start deploying Orion. So what we do is we measure the deployment sites or site against the company as a whole. So the green line is the site or accumulation of sites that we are deploying. The red line on the bottom is the percent of drivers deployed. You can see we haven't deployed any drivers yet. And the line matches pretty closely to the company as a whole. So the site is performing the same as everybody else up until deployment. Once deployment starts, look what happens to that metric. It separates from everybody. And as I said, we call this the Orion Curve because we've seen this 1,000 different times in the 1,000 sites we're deploying. And you can see that improvement in performance is commensurate with the percent of drivers we're deploying. Of course, we only took credit for the gap. So if everybody got better, the Orion sites had to get better above and beyond that. We were ready to launch early 2012. We were ready to launch. We had one algorithm, we had 1,200 locations to get to, and we had 60,000 drivers, and we had dispersed teams throughout. So there were about, at the time, 200 people deploying Orion. They were on teams of 5 or 6, and they were going off to sites to deploy. When they were done, they go off to the next site. We started measuring deployment benefits. The green dashes are the estimated benefits that we told the C-suite and the board that we would achieve. This has been cleansed a little bit, but that's what estimates we said. As we started deploying in 2012 with the teams, the first group of sites did exactly what we saw every place else. They were above the benefit estimate, thought that's great, gave high fives, and everybody moved on to their next set of sites. As they moved on to deploy the next set of sites, take a look what happened to the sites that were already up and running. This is the one thing we didn't test for in our 11 tests. It wasn't a long-term test, it was a short-term test. You know, to you, that's 3 dots on a line. To me, it's 12 weeks I'm not getting back of my life. And we became a flavor of the month. We became a flavor of the month because when the focus was on, people did and changed their processes, but when it left, they went back to their old ways. So we realized change management needs to be part of anything that deploys. So we need support from the top, and we educate and communicate and educate and communicate over and over again. We continue with trainings and certifications, and just as much, we come up with new metrics that defines what behaviors we want. What I learned is if you don't change a conversation, you become a flavor of the month. So I like to listen to what people talk about in the morning. If they talk about the same thing they always did, you're a flavor of the month. We need to change that conversation. And we did it with something as simple as new metrics. This is a balanced scorecard. It measures sites, it measures people, and it's simple red, yellow, green. And it, you know, it's a view over time. An important part of the balanced scorecard, these were leading indicators. They were things that the front line could control. So the front line was not measured on how many dollars they saved, that's lagging. They were measured on, did you maintain your data? Did the plan you put out, is it of quality? Are you overriding the system, and are you following the solution? Because if you're doing those 4 things, how can the lagging benefit of dollars saved not happen? That's not their fault. They did what we asked them to do. So we worked on that. As we ended 2012, we ended up decent, about in the middle of the estimate range throughout for the year. By the way, that very last point in there is Christmas, and we didn't even know if it was going to work on Christmas. So we were happy. As we look at deployment over time, you could see what happened with the benefit estimate. It continued to grow. And in fact, if you see those red lines move up, that's because we increased our benefit estimate multiple times. I don't understand, well, I do understand now, but what happened wasn't something that we projected. Sites continued to get better. They did better in their second year than their first, and their third than their second, and their fourth than their third. They continued to improve, and that's because they learned new ways to use the system. The change had actually taken hold, and they were driving it. They were coming up with new ways to actually use these optimizations. Overall, the initial round ended up with 100 million miles driven a year. That's an additional 10 million gallons of fuel not being purchased, an additional 100,000 metric tons of CO2 not going into the atmosphere. Again, this is when I retired. The benefits have increased about 50% from these numbers since I retired, because this was a process with plans to increase. One last video. And what I want you to listen to on this video is the change. This is from the people in the front line, but listen to how they own this system. Listen how the change has taken hold and how this is just part of what they do.
This was drastic for us. It changed the way we load the trucks. It changed the way we plan for the driver to deliver. It changes the way the driver delivers the route.
Orion has taken a situation that was good before and made it even better.
It'll show us our entire day from beginning to end.
It has shown me possibilities that I would have never thought were possible.
We used to get excited about a 1% gain in stops per mile. And to see some of the daily operation results now over 10% easily and even higher, it's really been incredible.
It tells you exactly how to drive to your first stop, and then also how you get back to the building from your last stop. So it allows me to focus on my safety aspects, lifting and lowering properly, and then also with my customers, addressing them properly, seeing how they're doing, and just being a professional.
From my perspective, it allows me to put more work on the cars. to make sure the driver doesn't have too little work and to make sure the driver doesn't have too much work. Orion allows me to put like that right amount of work on.
It's also been impressive to use the technology for peak season.
The amount of work that UPS sees is essentially doubled. With this tablet, I'm able to pretty much pull any route that we have in a building without having any prior knowledge of said route.
Being sent myself to an area that I'm unfamiliar with and using the tablet and the technology and being successful takes just a few challenges out of the mix for us from the many challenges that we have at peak.
Let's say if I'm on the road for a 9.2-hour day, and a year ago I did 110 stops, now I can do 115, 118 in the same amount of time.
Our carbon footprint, the miles that we save, the time that we're paying a driver to deliver boxes, wear and tear on the vehicle, on the road systems, oil changes, all of the above. I mean, it impacts everything we do.
As you can see, we're all pretty proud of Orion. Let's close with best practices. Let me summarize what we said. You focus on decisions and work backwards. What are the best decisions you need to make, and then figure out the information to make those decisions, the tools needed to supply the information, and then the data needed to feed those tools. I think a leader should understand the different type of analytics and what each can do and what they can't. Organizations should invest in data. Data is always going to be a bottleneck, so you need to understand and mitigate those limitations. Analytics need to be part of a process. Nobody wants to have a job to do and have the analytics on the side. They all fit together. Don't wait for a perfect system. Orion, as it deployed, I told you there was a roadmap to get more gains. So the last 50%, the additional 50% happened after the initial deployment. Need to embrace change management, and then finally do what you're doing here. Learn from others and network. As you know, I'm fond of Informs, so if you're not all Informs members, it's a great place to be. It's the best investment you'll make. It was that way for me. If you join Informs, become part of the Analytics Society. I've been a member of that since day one. Most importantly than any of it is build a great team. This is a very, very small portion of our team. There's IT people, engineers, project managers, domain experts, and this was from some magazine cover somewhere. And with that, thank you. I've got time for questions. I think we maybe 15 minutes left, and I'll stay as long as you all want.
I'm going to unmute so we can officially clap.
Yeah, thank you.
It was awesome. Thank you.
It was absolutely brilliant. Amazing, amazing. Even Jeopardy, very, very special. And Nova, congratulations.
Yeah, thank you, Jack. And actually, I guess I have a quick question just for information purposes. We actually attended a talk recently where they talked about including the search for parking, especially in big cities, urban areas, when a driver needs to deliver a package. Is any of that part of the decision making process at UPS at this stage? So
is it part of the systems? That answers no. And I've looked at that many times, and I'll fill you in for a second. The parking issue is an issue, especially in the large cities. There's rumors, and I don't really know the numbers, but UPS pays a tremendous amount of parking tickets in New York City.
Yeah.
I'm sure it's in lots of places. But keep in mind, for my job, those big cities were 2% of UPS. So I couldn't have those cities be the reason of not doing things. And honestly, initially, the initial plans for Orion deployment did not have deployment to those cities. As it turned out, the benefits were so great, we deployed to them anyway. We didn't expect it. Now, I did work, and I don't know what's going on now, but I did work with a number of firms that were working on parking. And the problem was at least at the time, everything was descriptive. You know, as you were pulling in, they would tell you where a parking place was, but that didn't mean that there was going to be a place available at the point the driver was showing up. We would have had to merge, this is when I'm going to get there, with a parking reservation. And that didn't exist. And we tried San Francisco, we tried a little test and a little bit in New York City, and could never get all that to align. But parking is certainly an issue.
I see. Thanks.
I have a question.
Sure.
Did some of your drivers initially resist because they wanted to do things their own way and not have technology tell them how to do things?
Great question. So it's almost like you knew, Anna. All right. So let me start with a few things. One, in our very first test in York, Pennsylvania, we learned something about drivers wanting to do their own way, or wanting to feel that they were part of it, or not being one to talk down to. This was our very first test, and we had on the counter in the morning that said something like your planned miles for the day. By the way, that prior to that didn't exist. There was no way to tell a driver how many miles you were going to run. Just whatever happened is what happened. So for the first time, we said, here's how many miles you want to run, that you should run today. And there was a human resistance to it. It was like, how dare you talk down to me? I'm a professional. One of my people came up with the simplest idea. He changed the title on the report from your planned miles to beat the computer. And now it was, okay, can you do better than this? And that became a challenge of drivers to see if they could do better than Orion. And that was just something we learned, beat the computer. Now, that being said, drivers, and especially Teamster drivers, can be a grumpy bunch. And, you know, they're good people, love them to death, but they don't want to be told what you have to do. So a lot of them, and by the way, think about it, they're paid by the hour. So not all the drivers are like the driver you saw in the video that says, I can deliver 118 stops for the exact same day. You know, I'm doing eight more. It's not the greatest sell to them in the world. It's just, this is the way it is. This is how we're able to afford wages for you that's the highest in the industry, much more than anybody else. So they just became part of it. It was a necessary part of the job of efficiency. I'll tell you a quick story about this one driver who, to this day, will tell you Orion doesn't work. He was running 165 miles a day out of York, Pennsylvania, and we told him he could run 150. And he came back in after his run and said, I told you Orion doesn't work. I ran 145 miles. So then we went and looked at what he did and changed the algorithm. And we said, okay, we now think you can do 135 miles. He said, I told you it doesn't work. I'm doing 130 miles. So we kept getting the algorithm better. He kept reducing his miles. He actually reduced like 30 miles a day. But in his mind, and I'm happy, Orion had nothing to do with that. It was him. And my point is, I'm a strong believer that the algorithm by itself and the human by him or herself is not as good as the algorithm working with the human. I encourage drivers to make their own decisions. I never expect anybody to run it 100%. If you see something the algorithm doesn't, traffic, a need from a customer, something not right, a package that's a bigger size, whatever it is, make the best decision, and we'll talk about it tomorrow. We have other tools that could say, was that the best decision? But I want drivers to go out and make their own decisions.
Thank you.
So maybe following up on that, I'm interested in the expertise that the drivers have, and about how often would a driver what percentage of the time if the driver wasn't going off of the Orion script or the Orion route, would they find a superior route?
There's a relatively small percent of time that they find a superior route. And in almost every case, they cheat, meaning that was meant to be a tongue-in-cheek word, right, by the way. But the drivers generally are just fantastic. So a driver says, I see a package that is going to take me 5 miles out and 5 miles back to deliver, but I know that Anna works at UMass. I'll drop it off at UMass because I know Anna. They become to know their people, so they do things that Orion can't do. That business that Orion says you have to deliver in the earlier part of the day, they may go, no, I know that they work later, I'll deliver it later. They do things more often than not that are things that the algorithm just can't do. So we encourage that. Every so often they beat Orion because there's bad parameters in the system. So remember I showed you that balanced scorecard? Yeah. Well, there's tools that fit into the balanced scorecard. We call it a top 5 report, FIVE, 5. So every morning there's a list of indices, and it says here are the top 5 drivers that are not meeting the indice. So it could be not following the solution, it could be running more miles, it could be overriding, it could be anything. And so every day you're working on the top 5. Every day you're working through it. And it could be that you have to fix a dispatch. It could be you have to fix a parameter, but you're constantly working on that. And that I learned in our initial test site, that, you in the morning, you're constantly working on the problem, because, working on the one that's pops to the top means now you're getting better and better and better, chiseling down. So.
Okay. Yeah. Thank you.
I have another question.
Yeah, sure.
I was wondering what percentage of the drivers tend to focus on a certain area or neighborhood? Because I would think that would be a real competitive advantage because they're more familiar with the habits and so on.
Yeah. So that's a great question again. So, it didn't seem like I'm going to give you more of an answer than you asked for. Sorry. But, UPS is a Teamster organization. And that used to be, in my mind, like a handicap. We have all the Teamster rules to follow, etc. But nowadays, when it's hard to find drivers, we have a stable workforce. We don't have this. It's somebody going to work for the best offer. Yeah. We have a stable workforce. Then what we also have is drivers bid routes. So every year, a driver bids routes. So there are drivers that are, the funny story is, look in some of the show. They're called the mayor of the town because they know everyone. They've been there all the time. There are drivers that when they retire are given retirement parties by their community. So that turned out to be an advantage because the drivers are there. They run the same area. The fringes, they don't. So every day the area moves a little bit. I think the rule is 75 or 85% has to be the same day to day. So there's rules into what you can change. And that turned into a competitive advantage, especially in these days, because they know how to maneuver through this, and some areas like, you get to an urban area like Brooklyn or something, you're delivering to apartment buildings. Knowing where to go, what neighbor to go to, knowing if I can give it to the doorman, knowing if I can put it in a room. That knowledge makes us successful. And then having the extras in that handheld also does. So,
thank you. Very interesting.
Thank you so much. So does anybody has one more question? We have time for one more.
I have one.
Okay, we have one from the room.
Thanks for a great presentation. In one of your last slides, you had a metric comparing the forecasted benefits versus the actual benefit. I'm wondering if you can talk a little bit more about some of the considerations that go into making a good forecast? Like, I saw that you kept updating it at different points.
Yeah, wow, great question. As you can imagine, you know, you got to put on your 2009 hat on. You know, we've got a system. It looks like it works. I've got to go ask for money, and I'm asking for a lot of money. I mean, a lot of money. And I showed you the package flow thing because that's what they were remembering. They invested in operations and it didn't work. Here, we're going to do it again. So I had to go in with good info. And, you know, where in this range do we estimate? So we went and did 11 tests. That was more than we expected to do. But what happened, on the side note, is we went in with a test and the C-suite said, this is a lot, this is great. In fact, the CFO, when I showed him our first results, said to me, your benefit estimate is amazing. This is great work. I'm assuming your estimate is over a 5-year period. I said, no, Kurt, this is for 1 year.
Wow.
And the C-suite said, nah, go test it again. And we tested again, got the same result. And they said, no, there's different areas, tested in a rural area, a suburban area, different environments, different management environments. So we did it again. But we had the same results everywhere. So what we did is we first looked at how many miles we could reduce, knowing that a mile's worth $50 million. We took the average and said, that's what we expect. We took the results of the worst site we had and said, that's the low end. Then we said, of a mile saved, the largest part of that time, the largest part of that mile savings is time. It's 82% of that. So you could save a mile, but not get the time off the clock. So we estimated what percent of the time would actually come off, and then we made sure we measured it. And we took that range and said, this is what we think we're going to do. That's what the first estimate was. In the second year, the change was taking hold, and we were above our benefit estimate after our second year. And my boss, after a heated conversation, twisted my arm and said, we're going to go and up the benefit estimate. Now, honestly, he was right. I didn't want to do that because I thought, why go from a success to a failure by saying we're going to do more? He was right. We raised the benefit estimate because we had achieved more. And in the third year, they beat it again. And it's because they kept getting better. The algorithm improved, but the sites were getting better in their second and third year because the change was taking hold. At that point in time, by the way, the board said, what do you need to do to go faster? That's the funny thing about benefit estimates. When you have something that's not have a good ROI, it's why are you doing it? And when you have something that's a good ROI, it's how fast can you go? So we went from 250 people to 500 people deploying to 700 people deploying the system, just so we could go faster. And so that's what went into the benefit estimate. By the way, if the things that are in there are the person's time, running cost, meaning that there's, you know, some small amount of time for vehicle maintenance, a little supervision, things like that, and then gas. So that's what makes up the time, but 82% of it is the person's time and 18% of it is running cost and, you know, the hard numbers. And we measure that every week. You know, we got this many miles, but we didn't get all of the time off the clock. And at the end of the day, we got about 95% of the time off that we estimated.
Okay, great. Thank you.
Sure.
Thank you so much. I could keep asking questions, but we're already above our time, and I'm going to be considerate of everybody's finding time in this final week of the semester. Thank you so much, Mr. Levis, for this amazing talk. I am going to steal some of your videos from my K-12 for sure. And thank you all of you who joined us, and we hope to see you next term.
And by the way,
Thank you.
if anybody wants to, the Edelman presentation for this is on Inform's website. And you'll see actually our CIO talking about it. Our CEO was there in person. You know, you may just want to see that and see what, you know, how this was so impactful.
I'm definitely gonna dig on it. Yeah, it's great to explain for the K-12 and talking about math and talking about the human side of it, which engineers and mathematicians tend to forget. So
thank you and congratulations for all the great work.
Thank you. Thank you.
Thank you.
Bye.
Bye-bye.
Bye-bye. Thank you.
Bye, everyone. Thank you.